Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड ईयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें ऑर्थोगोनल ट्रांसफॉर्मेशंस विषय रे पढिबा ऑलरेडी हमें देखिला जे गोटे रिजिड बॉडी रो configuration को completely specify करिवा पाई we need 6 independent coordinates okay out of those 6 3 will represent the center of mass and the other 3 are nothing but 3 angles representing the respective orientation of the rigid body okay अच्छा ताले orthogonal transformation कोन देखो जो आमे जनरलाइज्ड कोऑर्डिनेट देखुतिला सेतिरे 9टा डायरेक्शन कोसाइन 9 डायरेक्शन कोसाइन्स आमे देखिया को पाइला सो ऑलरेडी तार प्रॉपर्टी आमे देखिला नाउ it is very convenient to change the notation and denote all the coordinates by suppose x okay माने x को लिखिला x1 y को लिखिला x2 z को लिखिला x3 ताले एबे हमरो जो इक्वेशन थिला जनरलाइज्ड कोऑर्डिनेट रो जो ट्रांसफॉर्मेशन इक्वेशन x1 डैश हे गला alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 similarly x2 dash x3 dash आमे लिखि देला हला in terms of beta and gamma coefficient right अच्छा now ए जो इक्वेशन हमें पाइला these equation will constitute a group of transformation equations from a set of coordinate that is x1 x2 x3 to a new set which is the prime coordinate that is x1 prime x2 prime x3 prime and in particular they form an example of linear or vector transformation which is defined by the transformation equation of the form that is x1 dash equal to ebe alpha beta जगह रे हमें a रो कोएफिशिएंट लगेबा ओके a11 x1 a12 x2 a13 x3 similarly x2 dash x3 dash को हमें लिखि देला ओके सो ये जो कोएफिशिएंट हला a11 a12 ओके सब all these are any set of constant obviously independent of x and x dash coefficient right so to simplify the appearance of many of the expression will also make use of the summation convention okay which was actually introduced by Sir Albert Einstein whenever an index occurs two or more times in a term it will be implied without any further symbols okay so the terms are to be summed over all possible values of the index so equation जो ऊपर हमें देखुतिला can be written most compactly एबे बहुत ही शॉर्टकट रे हमें एबे समेशन कन्वेंशन यूज करी कि xi dash equal to aij xj ओके पूरा समेशन को भी हटे देला ओके दिस इज द कन्वीनियंट फॉर्म i रो वैल्यू 1 2 3 एतकी रहिला ओके सो द रिपीटेड अपीयरेंस of the index j यदि repeatedly appear kala index j this will indicate that the LHS left hand side of the equation is a sum over the dummy index j eta tome already mathematical physics रे पढुतबो ओके कोवेरिएंट कंट्रावेरिएंट टेंसर जो अछि सेठी यार डिटेल कांसेप्ट तमे पाइ जबो सो द सम ओवर द डमी इंडेक्स j फॉर ऑल द पॉसिबल वैल्यूज एंड हियर j वैल्यू भी 1 2 3 ही रहिबो so some ambiguity is also possible where the powers of an indexed quantity occur and for that reason the expression such as यदि यही बड़ा expression अछि summation over I xi square this appears under the summation convention like xi okay square को हमें यही बड़ा product करके लिखिबा so for the rest of the book summation convention को हमें assume करिबा और apply करिबा in reading the equation unless otherwise explicitly indicated jodi nathibo. Okay, acha. So where convenient or to move the ambiguity, the summation sign may be occasionally displayed explicitly. For example, when certain values of the index are to be excluded from the summation. Okay, so ଯାହା ବି ହଉ ଏଇ जो ट्रांसफॉर्मेशन ଆମେ ଦେଖିଲା ଉପରେ equation 4 to 11 रे the transformation represented by these equations is only a special case of the general linear transformation, which is equation 4 to 12. And since the direction cosines are not all independent, आमे देखिला सब direction cosine पूरा पूरी independent नुहंती, so the connection between the coefficients जो equation 4 to 8 रे देखिला may be re-derived here in terms of the newer notation. And since both coordinate system are Cartesian coordinate system x, y, z axis mutually perpendicular, so the magnitude of a vector is given in terms of the sum of the squares of the components. And further, since the actual vector remains unchanged no matter with the coordinate system jaha bhi tame use korche, actual vector ta unchanged rahuchi, the magnitude of the vector must be the same in both the coordinate system. That means in symbol we can state that the magnitude is invariant. That means xi dash xi dash will be equal to xi into xi. Okay, acha आगु बढ़िबा. Now left hand side equation 4 to 13 याकू आमे ई भलिया लिखि परिबा. एबे कोएफिशिएंट जो आमे पुट कर देला जदी aij aik xj xk. Okay, and it will reduce the RHS side of equation 4 to 13 if and only if. एबे देखो aij aik जो ए प्रोडक्ट अछि दुईटा कोएफिशिएंट रो either 1 हबो किंबा 0 हबो. 1 केते बेले हबो if j is equal to k और 0 केते बेले हबो if j is not equal to k. So याकू आमे कॉम्पैक्ट फॉर्म रे उठे क्रोनेकोड डेल्टा सिंबल असाइन करि परिबा. aij aik should be equal to delta jk. Okay, jk रो वैल्यू 1 2 3 ए बोला रहिला. Okay, and when the aij coefficients are expressed in terms of alpha beta gamma जोटा हमें फर्स्ट देखुतला, the sixth equation जोटा ऊपरे हमें already देखिला becomes identical जोटा हमें फर्स्ट देखुतला. Okay, so any linear transformation जोटा equation 4 to 12 रे हमें देखिला that has the property required by the equation 4 to 15 will be called as an orthogonal transformation. Okay, and equation 4.15 itself is known as the orthogonality condition. याकू हमें orthogonality condition बोली के कहिबा. Thus, the transformation from coordinates which are fixed in space to coordinates which are fixed in the rigid body. हमें दुईटा coordinate system देखिला, गुटे हैला body coordinate system आ गुटे हैला space coordinate system. So एई दुईटा जो transition होउची body रू space बा space रू body. Okay, से transition को represent करिवार अछि with common origin. It will be accomplished by means of orthogonal transformation. Okay, so the array of transformation quantities, that is the direction cosines जोटा हमें a coefficient देखुतिला already a matrix हमें पाई थिला. Okay, this is a 3 cross 3 matrix which is called as the matrix of transformation or orthogonal transformation matrix, and it will be denoted by capital letter a. एटा को बोल्ड करा हिची देखो. सो तमे लिखिला बेलको a लिखिकी आ ऊपर वेक्टर सिंबल भी दे पारिबो, किछि असुविधा नै. Now the quantities, that is the coefficient aij, are correspondingly known as the matrix elements of the transformation, right? And to make these formal consideration more meaningful, let us now consider the simple example for the motion in a plane. Okay, गोटे plane रे अबे हमें motion को as an example नबा, so that we are restricted with two dimensional coordinate system because plane coordinate नहीं जो हमें ताले the indices in the above relations can take on only the values 1 and 2 out of 3 ରହିବ नहीं because two coordinate system नेला ताले transformation matrix टा एबे 2 cross 2 को reduce करिगला एई भलिया. Okay, so that the four matrix elements are now connected by three orthogonality condition, that is aij aik equal to delta jk but with jk equal to 1 and 2, and therefore only one independent parameter will be needed or required to specify the transformation. ओके सो ये जो conclusion हमें देखला it is not quite surprising. A two-dimensional transformation from one Cartesian to another will correspond to a rotation of the axis in the plane. Okay, the simple kotha. And such a rotation can be specified completely by only one quantity, which is nothing but a rotation angle, suppose phi. Okay, so ଏବେ ୟାକୁ ଆମେ express କରିବା. Okay, in terms of single parameter transformation equation को ଆମେ लिखिପାରିବା x1 dash equal to x1 cos phi plus x2 sin phi. Okay, देखो cos phi और sin phi ଜାଗାରେ ଆମର coefficient ଥିଲା. Okay, a11 a12. Similarly x2 dash equal to minus x1 sin phi plus x2 cos phi. Okay, এই হিসাବରେ ଆମେ transformation କରିଦେଲା with the rotation angle phi. So you can see ଏବେ ଏଇଟା ହେଉଛି ଏଇ ଯେଉଁ ରୋଟେସନ୍ ଷ୍ଟାର୍ଟିଂରେ ଇନିସିଆଲି ଥିଲା x1 ଏପଟେ ଆଉ x2 ଏଇପଟେ ଦିସ୍ ୱାଜ୍ ଆୱାର ପୋଜିସନ୍ ଭେକ୍ଟର ରେଡିୟସ୍ ଭେକ୍ଟର ତାପରେ ୱିଥ୍ ସମ୍ ଆଙ୍ଗେଲ୍ ଫାଇ ଆମେ ୟାକୁ ରୋଟେଟ୍ କଲା ଇନ୍ ଦ କାଉଣ୍ଟର କ୍ଲକ୍ ୱାଇଜ୍ ଅର୍ ଏଣ୍ଟି କ୍ଲକ୍ ୱାଇଜ୍ ଡାଇରେକ୍ସନ୍ ତାହେଲେ ଏଇଟା x1 ଟା x1 ପ୍ରାଇମ୍ କୁ ଗଲା x2 ଟା x2 ପ୍ରାଇମ୍ କୁ ଗଲା okay and we have recently got the relation between the primed and non-primed coordinates then ଏବେ matrix element ସହିତ ଆମେ ୟାକୁ ଇକ୍ୱେଟ୍ କରିବା ତାହେଲେ a11 ହେଇଗଲା cos phi a12 ହେଇଗଲା sin phi a21 minus sin phi a22 cos phi ତାହେଲେ matrix पूरा matrix ଟା ଆମେ लिखि परिबा a matrix will be this much अच्छा ताले एबे तीनटा जदि हमें नहीं गला orthogonal condition which will expand into the equation like this okay a11 plus a21 will be equal to 1 you can put the value 1 hi bahari yar value ta a12 plus a22 equal to 1 and finally a11 plus a21 equal to 0 right these conditions are obviously satisfied by the matrix 4 to 17 jota a matrix ta and for in terms of the matrix element 4 to 17 they will be reduced to the respective identities যদি ଏବେ ସବୁ coefficient of value ଗୁଡ଼ା put କରିଦେଲା ତାହେଲେ ତ ଆମେ ଜାଣିଛୁ cos square phi plus sin square phi 1 ହିଁ ହେବ similarly sin square phi plus cos square phi 1 ହେବ ଆଉ ଏଟା ହେଉଛି ତମର ଯୋଉ cos phi sin phi minus sin phi cos phi its value is obviously 0 so the transformation matrix A can be thought of as an operator okay এই जो ट्रांसफॉर्मेशन मैट्रिक्स हमें देखुछु इट इज एक्टिंग लाइक एन ऑपरेटर सो এই ऑपरेटर जेतबेले एग्जीक्यूट करूची okay acting on the unprimed system then it is transforming this into the primed one okay so symbolically जदि এই प्रोसेस को हमें लिखिबा ताले देखो जो हमें देखुतला रेडियस वेक्टर बा पोजीशन वेक्टर r प्राइम बा r डैश is nothing but equal to a r okay so which is to be read as the matrix A operating on the coefficients or on the components of the vector in the unprimed system will yield the components of the vector in the primed system. Okay. Now, it is to be emphasized that the development of the subject so far that A is acting on the coordinate system only. Okay, and the vector is unchanged here. So we ask merely for its components in the two different coordinate system. Okay, a parenthesis हमें लगेगा has therefore been placed around the vector r on the LHS side to make it clear and to represent it as the same vector which is involved on both sides of the equation, right? अच्छा, only the components actually देखिवा यदि these components have been changed and in two dimension the transformation of coordinates it has been seen that it is simply a rotation जोटा देखुतला through an angle phi होतला so ये जो transformation matrix A is then identical with rotation operator in case of your plane coordinate system okay that is two dimensional now despite this it must be pointed out that without changing the formal mathematics A can also be thought of as an operator which is acting on the vector r and changing it with a different vector that is r prime माने non prime को बा unprimed को primed बने देला so r dash equal to simply ar पाइला से जो हमें previous relation टा देखुथिला से हिसाब रे एटा लिखा हिची with both the vectors expressed in the same coordinate system okay thus in two dimension instead of rotating the coordinate system counterclockwise one can simply rotate the vector r clockwise by an angle phi to get the new vector r dash eka kotha. Okay, so the components of the new vector will then be related to the components of the old by the same equation jota 4 to 12 tame dekhutila. Okay, that describe the transformation of the coordinates. Okay, and from a formal standpoint it is therefore not necessary to use the parenthesis jota ame first dekhutila 4 to 18 re. Rather it can be simply written like this. Okay, and interpreted equally as an operation on the coordinate system mane rotation eta korauche ei jo transformation vector ta, and the algebra also eta be same hi roibo no matter what will be the 2 points of view is followed. Okay, so interpret jodi kariba, the interpretation as an operator acting on the coordinates is more pertinent one, and when using the orthogonal transformation to specify the orientation of the rigid body. On the other hand, the notion of the operator changing from one to another has the more widespread application. Okay, mathematical discussion को जदि आमे देखिबा आइदर इंटरप्रिटेशन ये देखैबो जोटा कि आमे आकु भी आउरी बहुत किछि ए जो ऑर्थोगोनलिटी ट्रांसफॉर्मेशन तार प्रॉपर्टी विषय रे डिस्कस करिबा देन यूलर्स एंगल रे तमे एटा देखिबाकू पाइबो. Okay, and of course it should be emphasized that the nature of the operation which is represented by the transformation matrix A will change according to which the interpretation is selected. Thus, if A correspond to a counterclockwise mane anti-clockwise rotation by some angle phi when applied to the coordinate system, then it will correspond to a clockwise rotation when applied to the vector. Okay, so उल्टा जिनसटा को ये कहला ताले याकू जदि आमे फिगर रे देखिबा देखो ए हिसाब रे ये याकू सुचैछि एटा हला तमरो अनप्राइम्ड रेडियस वेक्टर बा पोजीशन वेक्टर. एबे देखो एटा क्लॉकवाइज पळे आसिला बाय एन एंगल phi, so that एबे तमे एठी प्राइम्ड वेक्टर r dash पाइलो. Okay, so this is the illustration of the interpretation of the orthogonal transformation as a rotation of the vector. Okay, leaving the coordinate system unchanged. एबे देखो coordinate system किछि भी change हेउ नाही. एठी x1 अछि एठी x2 अछि, केवल वेक्टर टा चेंज हेगला by some rotation that is phi. Okay, अच्छा ताबरे these are some handwritten rules. Okay, so first figure रे जो हमें देखुतिला orthogonal transformation, it has been shown to be the rotation of the coordinate system with the vector remaining unchanged हैला. तापरे ए जो इक्वेशन तमे केमती पाइलो एटा एठी यार माने डेरिवेशन टा कराइछि ऑलरेडी तमे देखुतिलो एपटे x1 थिला एपटे x2 थिला. जदि रोटेशन करूछो बाय एन एंगल phi एपटे पाउछो x1 प्राइम एपटे पाउछो x2 प्राइम. केमती एटा आसिला सपोज आमे गोटे पॉइंट नेला p. ओके, p पॉइंट नेला तापरे एठू परपेंडिकुलर एठी आमे नेला pq. ओके, नाउ यू सी OQ को ए पोर्शन को आमे नै गला टू बी इक्वल टू x. PQ हे गला ए जो वर्टिकल पोर्शन इट इज इक्वल टू y. तापरे OM जते बळे एटा रोटेट करि जाउची. ओके, रोटेट करि जाउची ताले अकॉर्डिंगली ए जो परपेंडिकुलर भी रोटेट करिवो. सो वी आर गेटिंग सपोज अ न्यू पॉइंट नाउ OM, दिस वन या को नै गला x प्राइम बा x डैश. आ PM जोटा हमर एबे न्यू परपेंडिकुलर एटा हे गला y dash. Okay, so x y और x dash y dash, these are the coordinates of this point P with respect to the unprimed and primed coordinate system respectively. ताले एबे x dash जोटा हेउतला हमरो OM can be written as OR plus RM. You can see in the figure OM माने this one एटा हे गला OR plus RM. याको एबे respectively x और phi हिसाब रे लिखि परिबा. OR will be equal to x cos phi. Now RM is nothing but equal to Qn. It would simply rectangular. Okay, RM and Q. ताले x cos phi plus y sin phi आसीगला जोटा हमें देखुतला रिलेशन. सिमिलरली y dash हेगला PM माने ए जो वर्टिकल डिस्टेंस टा which is equal to Pn minus Mn. Okay, Pn माने ए टोटल डिस्टेंस टा minus Mn याको काटी देबा ए जो वर्टिकल डिस्टेंस. ताले y cos phi minus x sin phi. ओके, ताले अबे हमें पाइला कोन x dash equal to x cos phi plus y sin phi. y dash equal to minus x sin phi plus y cos phi। ଆଉ ଯଦି ଆମେ x1 x2 ହିସାବରେ ଲେଖିବା ମାନେ x କୁ ନେଇଯିବା x1 y କୁ ନେଇଯିବା x2 ତାହେଲେ x1 dash equal to x1 cos phi plus x2 sin phi ଆଉ x2 dash equal to minus x1 sin phi plus x2 cos phi। Okay, so this is all about your orthogonal transformations.
Thank you.